Hello viewers, welcome back to my channel. This is the first video lesson on scalars and vectors. In the course of this video lesson, we are going to look at the definition of scalar and vector quantities, and thereafter we'll look at some examples of scalar and vector quantities, and lastly we'll look at some practice questions. So by the end of this video lesson, you should understand the meaning of scalar and vector quantities, and also you should be abreast with some examples of scalar and vector quantities, and thereafter you should be able to apply this knowledge in answering questions. So do well to get your writing materials and let's get started. So we begin this video lesson by looking at the definitions of scalar quantities and vector quantities. But before we do that, let's take a look at this illustration. So let's say we have a young man, and this man is called John. So John woke up on a particular day and decides to leave his house and take a stroll because he is bored. So he left his house, and along the way, he decided to visit a friend called A. Then at a certain point, when he left the house of A, he went to the house of B. And from B, he went to the house of C. And from C, he later moved to the house of D. So in doing all of this, John has covered a certain distance. So let's say from here to here is 2 meters. From A to B's house is also 2 meters. From B to C's house is 2 meters. And let's say from C to D's house is 3 meters. So in total, he has covered a distance of 9 meters. So this 9 meters is a size or a magnitude. So in essence, John has covered a particular distance which has magnitude, but in real sense, it has no direction. So in a case where a quantity has size, but there's no direction, we'll call that type of quantity a scalar quantity. Hence, scalar quantity is defined as those quantities that have magnitude. Now, this word magnitude here just simply means size. So they have size, but there is no direction. So in physics, direction are represented by 4 major cardinal points. And what are those cardinal points? We have the north towards the top. We have the west towards the left. We have east towards the right. And then we have south. Now, there can be more than 4 in the sense that between north and east, we can have what we call northeast. Between south and west, we can have what we call southwest. Between north and west, we have what we call northwest. And then between south and east, we have what we call southeast. So a magnitude that has size but no direction is rightly referred to as a scalar quantity. So let's take another illustration. Again, on a particular day, John woke up on a particular day, or let's say in this case, Martins. Now, Martins decided to visit a restaurant. So let's say this is a restaurant that Martins decides to visit because he is hungry. And then he moves straight towards the restaurant. So let's say in this case, he moved eastward towards the restaurant. And between his house and the restaurant, let's say it's 10 kilometers. So in this particular case, we have a size for the distance between Martin's house and the restaurant. And then there's also a direction. So when a magnitude takes direction, we call that quantity a vector quantity. Vector quantities are those quantities that have magnitude and direction. So they have a combination of both magnitude and direction. So now let's summarize this. Every quantity, either scalar or vector, they both have magnitude. So every quantity you can think of in physics, they have a size, time, 5 seconds. If we say length, 6 meters. If we talk about mass, 10 kilograms. So any quantity we can think of, they have magnitude. But the difference now lies in terms of their direction. So for scalar quantities, they have no direction. But for vector quantities, they have direction. Hence, to summarize this, scalar quantities are those quantities that have magnitude but no direction, while vector quantities are quantities that have both magnitude and direction. So here is a table showing some examples of scalar and vector quantities. Now for scalar quantities, good examples you should take note of are distance. Distance is a quantity that has magnitude but no direction. Now speed is distance over time. Since distance is scalar, automatically speed is also scalar. Other examples are mass. Mass has magnitude. For example, we can say 10 kilograms but it has no direction. The same thing with time. Time has magnitude. For example, 5 seconds, but we cannot say time is moving northeast, northwest, northeast, west, or south. Now, the same goes for temperature and also for energy. While good examples of vectors we have are displacement. For example, displacement, we can write it as 10 meter, then let's say north, 60 degree east. So this is magnitude, that's the size, and then this is direction, not 60 degrees. So velocity is simply displacement over time. Hence, velocity is a vector quantity. So we have acceleration, which is vector. We have force, we have pressure, and then we have momentum. Momentum is a vector quantity. It's equal to mass times velocity. But because velocity is a vector quantity, hence momentum is a vector quantity. So here's a trick. If you find out that one of them is a vector quantity in a particular formula, know that the formula itself is a vector quantity. So what I just said here was that, or let's take the case of force. Force is equal to mass times acceleration. Mass times acceleration. Mass, though, is scalar, but because acceleration is vector, automatically force is vector. The same goes for pressure. Pressure is force over area. Now, area is scalar, but force is vector. So because force is vector, pressure is a vector quantity as well. Now, the same goes for momentum. Momentum is simply mass times velocity. Though mass is scalar, but velocity here is vector quantity. So automatically, momentum is a vector quantity. So that's a simple trick. But then I'll tell you something on the next slide. So we have density, which is a scalar quantity. Density is mass over volume. Both mass and volume, they are both scalar quantities. So we have power, we have length, we have area, we have work, and then rather we have volume, and lastly we have work. So for vector quantities, we have what we call impulse, we have torque, we have electric field, we have magnetic field. The fields are all vector quantities. We have electric force, and then we have angular velocity. We also have what we call angular momentum. They are all vector quantities. So here is something worth knowing. Let's say we have a quantity A, and A is equal to B times C. And then B is a scalar quantity, and C is a vector quantity. So when we have a scalar and a vector quantity multiplying each other, or possibly dividing each other, their product or division will end up giving us a vector quantity. So that's why in the case of momentum, where we said momentum is equal to mass times velocity. Now you get to see that in this case, mass is a scalar quantity, velocity is a vector quantity, and their product will end up giving us a vector quantity. Now when we have two vectors multiplying each other, so let's say again we have A is equal to B times C, but B is a vector quantity and then C is a vector quantity. So whether they are multiplying or dividing each other, you end up getting a scalar quantity. So in physics, it is said that the product of two vectors, or the dot product of two vectors, will give us a scalar quantity. Now a good example is when we have work. Let's say we have work to be force times displacement. Force times displacement. Now you get to see that force here is a vector quantity. Displacement also is a vector quantity. At the end of the day, work is a scalar quantity. So the same goes for when two scalars multiply or divide each other. So let's say we have B to be scalar and then C to be scalar. Both of them don't have direction, so there is no way A will end up having direction. So A will also be a scalar quantity. So take note of this. A good example is when we have speed. Speed, for example, is equal to distance over time. Now, distance is scalar, time is scalar, so automatically speed also is scalar quantity. So here are some practice questions to help us understand the introduction to scalar and vector. And the first question, which is a JAMB 2021 question, read, which of the following is not a vector quantity? So if the quantity is not a vector quantity, that means that it is a scalar quantity. And momentum is a vector quantity. So we are going to take out momentum. Force is a vector quantity. So we are going to take out force. Displacement is a vector quantity. So we are going to take out displacement. So automatically we are left with temperature, and temperature is not a vector quantity because it is a scalar quantity. So temperature is the answer to this JAMB 2021 question. The second question says one of the following is a scalar quantity, and this happens to be a JAMB 2022 questions. Option A is weight, B is momentum, C is potential energy, and then D is displacement. So for weight is a special type of force due to gravity. So weight is a form of force due to gravity. So this is a form of force due to gravity. And remember, we said that force is vector quantity. So automatically weight cannot be the answer. For momentum is a vector quantity, so it is not a scalar quantity. Then for displacement, it is a vector quantity, so it is not a scalar quantity. So our answer to this question is potential energy. If you remember, energy is a scalar quantity, so potential energy is just a type of energy. So automatically, the answer to this question is option C. So weight is out of the option. B, momentum is out, and D, displacement is out. So our answer to this question is potential energy. So the third question says, which of the following quantities? So the third question reads, which of the following quantities is described by both, emphasis on the word both, magnitude and direction? So like we rightly know, vector quantities have both magnitude and direction. So they are indirectly asking us which of the following is a vector quantity. So that's what we are being told to look for in this question. So which of the following is a vector quantity? So time is a scalar quantity. Distance is a scalar quantity. Speed is a scalar quantity. So the answer to this question is option D, acceleration. And acceleration happens to be a vector quantity which has both magnitude and direction. Now the fourth question reads, a scalar quantity is defined as a quantity that, now for scalar quantity, we know them to have magnitude but no direction. So automatically the answer to this question is B. They have only magnitude or magnitude only. And like I said earlier, magnitude means what? Size. So magnitude means what? Size. Take note of that. So you could probably be given size is same thing as magnitude. So the last question reads, a vector quantity is defined as, for vector quantities, we know them to be quantities that have both magnitude and direction. So our answer to this question is option A. Vector quantities have both magnitude and direction. So viewers, I hope you learned something from this video lesson. Do well to like this video and also share this video lesson with your friends. And if you haven't subscribed to this channel, do well to click on the subscription icon and also turn on the notification bell so that whenever I release a new video, you always get notified. See you in the next one.